June 2002, and the Greater London Assembly Building on the banks of the Thames is nearly complete. It's a state-of-the-art design, but whether it'll be as good inside as out is largely down to 28-year-old engineer Sara McGowan.
Ultimately, if the people in the GLA building are unhappy in the space, then I suppose it's my fault, yes. When you look at buildings, you tend to look at the outside of them and say, oh, that building looks nice, it's, you know, a beautiful piece of architecture. But that on its own isn't enough, because if the services systems in the building aren't designed properly, people won't enjoy being inside the space. I'm a building services engineer, which means that I'm responsible for designing systems to control the internal environment inside buildings. I was, in fact, the building services engineer for the GLA building, which involved designing all the mechanical systems, doing a lot of work on the facade design, and deciding how we were going to control the building. It's a bit of a juggling act, really, balancing the design criteria that the client sets, trying to keep the energy consumption of the systems down as much as possible. But ultimately, our main aim is to ensure that the occupants are comfortable.
The brief was to build a new landmark for London, a fitting partner for the old ones beside it. The new City Hall has been one of London's most politically sensitive construction challenges, with the design of building and the progress of the engineers under constant public scrutiny. GLA will have 10 floors above ground and a steel frame of over 2,000 tons. As well as the architectural challenges of the build, the brief insists that the building must be energy efficient. But how do you keep everyone comfortable and stay green when there are over 7,000 square meters of glass?
The fundamental difference is that we don't have chillers to do the cooling. So we're actually using borehole water. Basically, we've drilled 2 wells down into the aquifer below London. We have a rising groundwater problem in London anyway, so using borehole water, there's plenty of water there. And basically we drill two wells down. They're about 100 metres deep. They've got pumps sitting in them about 70 metres down, and that pumps cool water up from the aquifer. It comes out of the ground at about 11 or 12 degrees, and we use that as our main source of cooling. It's a free source of cold water, basically. You just have to pump it out of the ground. It obviously depends where you are and what the availability is, and you couldn't have, 6 buildings next to each other all pumping water out of the ground necessarily, because in some areas that would deplete the aquifer and the water temperature would start to rise. But here in London, certainly for this building, there was no problems. We run it through the building and then discharge it into the Thames. Seeing the GLA finished now is fantastic. My office is in central London, and it's a great location to work. It's close to Oxford Street, close to all the shops. It only takes me about half an hour to get into the office in the mornings, which is a great commute for London. It's brilliant.
Sara works for one of the biggest firms of consulting engineers in the world. Their job is to take ambitious designs for things like buildings and bridges and to find out how to make them work. It often involves going back to first principles.
Without applying science in some way to the problems that we're given, we wouldn't be able to solve them in a new way. And you have to go back to first principles and think, okay, I don't know how this will react because we've never used it before. So from what I know of how, the properties of this system, this is what will happen. Without having a knowledge of the thermodynamics behind those things, you wouldn't be able to do that.
For the GLA building, Sara's team worked out exactly how much heat from the sun fell on each of the building's 600 windows and did the calculation for every day of the year.
Once we've sized the systems, we'll actually produce a schematic of it, which allows us to size all the pipework runs, all the distribution, all the ductwork, and that all goes onto a schematic, which in our terms is actually the most useful drawing because it shows everything. And this is the drawing that the contractor takes and prices against because it shows every single valve, every connection, everything in the job. This particular schematic is the chilled water schematic, which shows our boreholes, and the cool water comes up from the boreholes and is then distributed through all the systems in the building. it's a fantastic thing to walk around on site and go, that's duct from AHU number 3 going to riser 2.
If you take this slab,
yes.
you take 650 off. Yeah, no, that's right.
On big constructions, lots of engineers work together, and Sarah is quite often the odd one out.
The team I lead is largely made up of men. There are occasionally issues. I've come in very rarely where an older engineer might not like the fact one that someone younger than them is their boss anyway, much less a younger female being their boss. It doesn't happen very often, but it has happened. And one of the skills that you need in my position is to be able to gauge how different people will react in different situations.
Well, as long as it's factually correct, we can give this to Nicola.
As the GLA building nears completion, Sarah moves on to her next challenge. While still involved in the City Hall, she's been promoted to take charge of the building services on a new project.
My current job is as the project manager for a new business park development in Hemel Hempstead. That means I have to go to site meetings, meet up with contractors, have a walk around site. Site tends to be a bit more aggressive than an office environment is. If something gets built wrong, then the impact of that is a lot more than perhaps getting a sum wrong and issuing the wrong number on something. And the guys on site are working to a different programme and a different speed definitely than we do during the design phase.
On a job like this, there are over 30 firms of contractors employed whose skills vary from ductwork to drainage. In the semi-permanent site office, regular meetings to update on progress avoid costly confusion.
Self-confidence is very important. Walking into a meeting room with 15 men who are all probably been in the industry for 20 years longer than you have can be quite intimidating. You'll spend an awful lot of the meeting just listening to what other people are saying because you might suddenly get asked a question, and at that point you need to know what's going on in your team so that you can respond to any question that might come up over the course of the meeting. But I don't want it to be an air pack. You've actually got that situation. It's a good team, we all get on very well, and if things are going reasonably well on site and everybody's very happy with what's going on, then the meetings can actually be quite good fun.
Their foundations all right?
Yes. I'm a member of a gym in Stoke Newington, which is about 5 minutes away from my flat. It really helps de-stress, particularly after a really, really long day.
Back at Hemel Hempstead, Sarah is one of the most senior people from her firm on this job. But she can't be on site all the time. She relies on the resident construction engineer, Louise Unicum, to be her eyes and ears.
When I come out onto site, I like to be able to have a walk around and just pick up on some of the things that have been mentioned in meetings and just get an idea for myself of exactly what the problem is and what the extent of the problem is. Sometimes in a meeting people can make a bit of a drama out of very small problems, and it's good for me to have a better idea of what exactly the issue is by seeing it for myself. Even though things are going well, there are still little aspects where, because it's happening so quickly, something goes in because they want to get that bit finished, and then they realise afterwards, oops, that wasn't quite what we meant to do. You can see, well, that's about to hit the purlin, and we need to go actually out through the roof, so they're going to have to actually cut back that piece of ductwork and put in a new section.
Yeah, it shouldn't hold up things too much.
That's
really,
it. It won't take long to do that. Fine. I like being on site, but I'm absolutely terrified of heights. So I like it when the stairs inside the building are fully operational and you can walk up proper stairs. Okay, well, if we go round to the front of the building first. As a building services engineer, we have the potential to have quite a large impact on the environment. At its most basic, reducing energy consumption in a building reduces the carbon dioxide given off by the gas or the electricity that you're using to power the machines that are making the building hot and cold. And the basic stuff like natural ventilation and passive cooling and all the things that you can do to get rid of the need for mechanical systems and again keep the energy consumption down. That has a huge impact on the amount of CO2 that the country as a whole produces and gets into the environment, and we have the biggest single impact on that area of design. The thing that's probably the most special about the design of the Hemel Hempstead buildings is the external louver system, which is like a giant Venetian blind basically, and that's designed to keep the sun out of the building. When the sun's at its strongest, it closes down, and it means that the building doesn't get too hot, we don't get direct sunlight onto people's desks, and the cooling system operates efficiently.
The blinds should open and close automatically, responding to inbuilt sunlight sensors. Sarah's team have been practicing with mock-ups to make sure they will work.
Some of the things in our specification, they weren't able to test them on the mock-up.
Right.
So we need to do a second test on the real thing to confirm the last few bits and pieces in the specification. So once they've got 3 banks up, we can do that, which means at that point we'll find out if there's any problems and we can fix them. But after work, I often meet up with my boyfriend Mike, and we try and meet up most evenings during the week just to have a bit of a catch-up. We'll either just go home and have dinner at one of our flats, or we'll go out. We try and get out and go out for dinner a couple of times a week just to completely switch off and get away from things and have a bit of relaxation time during the week. Otherwise you do find that you just go to work and go home and then go to work again, and I think it's very important to maintain a life outside work. I think it helps you in your work if you have a strong life outside work.
Yeah, no, she came back yesterday. Tuesday.
I think that the career I've chosen has given me a very good lifestyle. I think that I'm comfortable enough that I can do the things that I want to do. I have a nice flat, I can get away for the weekends, you know, and I'm able to do that because I have the time and I guess the disposable income to do it. It smells very nice. Hello, how are you doing? I'm fine, how are you? Yes, very well, thank you. I've got quite a good group of friends in London. Some people who are engineers, but some wonderful people who aren't engineers. We can actually have a conversation not about work. We try to meet up fairly regularly. I sort of catch up with various people at different times during the week, and one of the things that we often do is go round to each other's houses for dinner and just have a bit of a gossip, a couple of glasses of wine, some nice food, and just relax, try not to talk about work. And I would say anybody that likes solving problems and likes science and is creative as well and doesn't quite know how on earth they can reconcile those elements, do engineering, because it is actually a very creative profession with a basis in science. And at the end of the day, you see a finished object and you can say, I did that.